Hello everyone and welcome back. I am Matias and I will be your host for this episode. This is part 3 of our Metroidvania tutorial series where we'll be teaching you how to create a Metroidvania like Hollow Knight in Unity. In the previous episodes, we covered the character movement. In this episode, we'll be creating a melee attack with recoil and an enemy type. Needless to say, Hollow Knight's melee combat system is one of its defining play experiences. Alright, enough foreplay. Let's get this show on the road. Firstly, let's set up the attack animation so we'll be able to clearly see if the attack function is being called. Let's create an animation clip and name it player_attack. Drag the sprites for the attack animation into the animator window and adjust it so that it looks good. We'll do the same for the jump attack as well and call it player_jump attack. Now, let's link it to the rest of the animations in the animator window. Now we want the attack animation to play completely when the player attacks instead of being cut off. So, we'll create a trigger called attacking and add it to the arrows leading towards the attack animations. Uncheck has exit time and change transition duration to 0. We don't need to put a variable in the arrows leading away from the attack animations, but we do need to check has exit time and change the exit time to 1. So, after the animation plays once, it will automatically switch back to the previous animation. As with before, uncheck loop time. Alright, let's go into the player controller script. Firstly, let's create a bool attack to check if we are attacking or not. And we'll create a float time between attack and time since attack so that we can't attack non-stop. This will also prevent a bug that will basically deal infinite damage to the enemy. Now let's create a function attack. In the function, we'll add time since attack plus equals time.delta time. And we'll put in an if statement if attack and time since attack is more than or equal to time between attack, then inside will reset the time since attack back to 0. What this does is if we are calling the attack input and the time since we last attacked is more than the attack's cooldown, we can attack again. Okay, let's add in the animation before testing it out. Right, so we want the left mouse button to be the attack button, so it's attack equals input.getMouse button down 0. Don't forget to add the attack function into update. Alright, let's test it out. Great, the attack function is being called and the attack animations also work. And as you can see, we can't spam attack. Now, we can start the fun stuff. Okay, before that, let's organize the script. Let's add a section for attacking in the namespace. Alright, so how we're gonna do the attack is basically detect if the target is within an attack area. So what we'll do is create 3 separate transforms and name them side attack transform, up attack transform, and down attack transform respectively. We'll set the side attack transform to 2.75, negative 0.7, the up attack transform to 2.5 for Y, and for the down attack transform, negative 3.45 for Y. We'll be casting an area from these points, which will determine the attack area. We'll create 3 transforms and name them side attack transform, up attack transform, and down attack transform respectively. Next, create 3 vector 2s and name them side attack area, up attack area, and down attack area respectively. Let's create an on-draw gizmos so we can clearly see the attack areas in the scene. Here, we'll put gizmos.drawWireCube side attack transform dot position side attack area, and copy paste that 2 more times and change it to up attack and down attack respectively. Let's make the wire cube red so we can see it more clearly. Now, in the inspector, we need to determine the size of the attack area, so we'll input the X and Y values. But first, we'll assign the attack transforms to their respective slots in the inspector. The values I'll be using is 4.5 by 3.5 for the side and 3.5 by 4.5 for up and down, but you can experiment with whatever values you like. So now we have our attack area set up, let's begin on the code to attack. But before that, we need to create an attackable layer to detect what we can attack when we do attack. In the inspector, create a layer called attackable. We'll leave it like this for now. We'll also create a layer mask, attackable layer, for this. Next, we'll create a function hit and put a variable attack transform and variable attack area in it. This is because, regardless of which direction we attack, we will call this function and we will set the specific attack transform and attack area when we call it. In this function, we want to be able to hit multiple objects and sift out what is attackable and what isn't. So we'll create a collider 2D array objects to hit equals overlap box all variable attack transform dot position variable attack area 0 attackable layer. Before we can test this out, we'll need to add this into the attack function. Firstly, we'll create a float, y-axis, and just like x-axis, it's also used for directional input. Just instead of horizontal, it's vertical. In attack, we'll add an if statement. If the y-axis is 0 or less than 0, and the player is grounded, hit side attack transform side attack area. So this sets the specific attack area to the side attack area when the player is not holding down W or S, or if they are holding down S and is grounded. Else if y-axis is more than 0, hit up attack transform up attack area to set the attack area to the up attack area if the player is holding W. And we copy paste this underneath and set it to if y-axis is less than 0 and not grounded, and down attack transform and down attack area for attacking below the player. Okay, for now, let's check if it works. So we'll check if the objects to hit is more than 0, call a debug log hit. For testing purposes, let's give this platform the attackable layer. Remember to change it back to ground later. Okay, great, it works. Now, we'll create an enemy and the damage function. So let's create a rectangle game object and name it enemy. Make it the same height as the player and add a box collider and a rigid body 2D to it. We'll freeze the rotation of the enemy. Create a script and call it enemy. For now, we'll just make a health and death function for the enemy to test the attack. Create a float health. We'll serialize it as well. In void update, we'll add if health is less than or equal to 0, destroy game object. So that's the death function. Now, we need to determine how much health the enemy has and what happens if it's attacked. So let's create a function for that. We'll name it enemy hit and add a variable float damage done. Now in the function, add health minus equals damage done. Okay, so now we'll move to the player controller. In the hit function, we'll use a for loop to iterate through the objects to hit array to detect if there's an enemy. If objects to hit.getComponent enemy is not null, objects to hit.getComponent enemy hit damage. Oh, I forgot to make the enemy hits public. We'll also need to add a float's damage to the player, so let's do that right now. Under attacking, add a serialized float damage. Okay, now let's test it out. Remember to set the damage and the health of the enemy in the inspector before playing. And don't forget to set the enemy to attackable as well. Excellent, the enemy dies and it works. Alright, now let's add a slash effect to the player attack to make it look nicer. I'll be using a Sword Slashes asset pack from itch.io. Once again, the assets we're using are in the description below. For this video, we'll be using the pure white slash wide, but feel free to use any of the slashes you wish to. Create an animation for the slash and drag in the sprites to the keyframes. Alright, now that's done, we'll rename this to slash effect and make it into a prefab. In the player controller, we'll add a game object slash effect so we can instantiate it. Now, we want the slash effect to be directed upwards and downwards as well as to the side. So we'll create a function slash effect at angle and add in a variable game object slash effect, variable integer effect angle, and variable transform attack transform. The slash effect will be instantiated at the various attack transforms. In slash effect at angle function, we'll define the variable slash effect to be instantiate slash effect attack transform. Then under that, we change the angle by calling slash effect dot transform dot Euler angles equals new vector tree 0 0 effect angle, since we are only rotating on the z-axis. After rotating the slash effect, we'll stretch it to fit the attack area, so we get its local scale. Slash effect dot transform dot local scale equals new vector 2 transform dot local scale x transform dot local scale y. Okay, in the attack function, we add the slash effect. For the side attack, instantiating it will be fine, as there is no change to its angle, so we'll just add instantiate slash effect attack transform. For up attack, we use slash effect at angle slash effect 90 up attack transform. And for down attack, slash effect at angle slash effect negative 90 down attack transform. Now, in the inspector, assign the slash effect prefab and let's test it out. Whoa, looks like we got a bug here. Okay, let's see. The position of the slash is not 0 0. And I also didn't uncheck loop time. Okay, now let's give it a go. There we go. However, we aren't done yet. If you take a look at the player, we have instantiated many instances of the slash effect, which will slow down the game. So we'll need to destroy the slash effect game object once the animation has played. We'll add the destroy after animation script to the slash effect game object. Now, if we attack many times, there won't be a flood of slash effect clones. Let's reduce the angle of the upward slash. Let's try 80 degrees. And play. Yup, looks better. Remember, do experiment with the values for your own game. Alright, with the slash done, let's add recoil to the enemy when it's hit. In the enemy script, add a float, recoil length, recoil factor, and recoil timer. Then, add a bool, is recoiling, and default it to false. Next, add a rigid body 2D, RB, and create a void awake, and add RB equals get component rigid body 2D. In the enemy hit function, add an additional vector 2 variable, hit direction, and float variable, hit force. Then we add if not is recoiling, rb.addForce, negative hit force times recoil factor times hit direction. So what this does is if the enemy isn't recoiling when it's hit, it will recoil in the direction that the hit comes from. Then in void update, we add if is recoiling, if recoil timer is less than recoil length, recoil timer plus equals time.delta time. Else, reset is recoiling to false, and reset the recoil timer back to 0. Okay, as you can see, an error is being thrown. If we move back to the player controller, we can see that the enemy hit here doesn't mention the hit direction and hit force, so we'll need to add that in. So we'll add transform.position minus objects to hit.transform.position normalized. Basically, what this does is it determines the direction of the player's hit. And finally, we'll sub in a hit force value, let's say 100. Okay, let's test it out. We'll need to assign a value to the recoil length and recoil factor. Let's say 1 and 50.
But there's one they fear. In their tongue, he's Dovahkiin, Dragonborn.
Excellent, it works. Let's also add recoil to the player every time they attack. Firstly, in the player state list, create a public bool for recoiling X and recoiling Y. Now in the player controller, add a section for recoil. Then create two integers, recoil X steps and recoil Y steps. This determines how far the player will recoil. Let's default both to 5. Also, create two floats, recoil X speed and recoil Y speed to determine the speed. Let's default both to 100. Make all of these serializable so we can fine-tune it in the inspector. Let's create a function called recoil. For the recoil, we'll create a bool looking right in the player state list. Now, in the function, we'll put in if pstate.recoilingX is true, if pstate looking right is true, rb.velocity equals new vector 2, negative recoil x speed 0, else rb.velocity equals new vector 2 recoil x speed 0. So if the player is recoiling in the x-axis, they will recoil left if they're facing right, and vice versa. Now for recoiling in the y-axis. If pstate.recoilingY is true, if y-axis is less than 0, rb.velocity equals new vector 2 rb.velocity.x recoil y speed. We can just do this as if the y-axis is less than 0, the player is attacking downwards. We use rb.velocity.x here as we want to keep the current x-axis velocity as we recoil in the y-axis. Also, add rb.gravity_scale equals 0 so the gravity doesn't affect recoiling. Okay, now, else rb.velocity equals new vector 2 rb.velocity.x negative recoil y speed for recoiling downwards when attacking upwards, and the gravity to 0 also. If the player isn't recoiling in the y-axis, reset the gravity scale back to the original. Oh, we also want to reset the jump counter back to 0 when we recoil in the y-axis. To activate the recoil, in the hit function, we'll add a ref bool recoil dar and a float recoil strength. Then, if we hit anything in the attackable layer, we make recoil dar equals true. We'll need to update hit in the attack function as well. For side attack, add ref pstate.recoilingX and recoil X speed. And for up and down attack, add ref pstate.recoilingY and recoil Y speed. Let's also change the enemy hit force to the recoil speed of the player, so we change 100 to recoil strength. Okay, now in the flip function, we'll add in if x-axis is less than 0, pstate.lookingright is false, else if pstate.lookingright is true. So we have the recoil, but now we need to stop the recoil, otherwise we recoil forever. We'll create two integers, steps X recoil and steps Y recoil. Then we'll create a function, stop recoil X. Here we'll set steps X recoil to 0 and pstate.recoiling X to false. We'll copy paste this below but change the X's to Y's. In the recoil function, we'll add in if pstate.recoiling X is true and steps X recoil is less than recoil X steps X recoil plus plus. Else we call stop recoil X. If we're recoiling, if we haven't recoiled the full distance yet, we continue to recoil until we do. Do the same for recoiling in the Y-axis. Then we'll add, if grounded, stop recoil Y. So if we're already on the ground, it'll stop recoiling. Now you may be wondering, what about recoiling upwards? This recoil is the attack recoil, and if we're grounded, we can't attack downwards, so recoiling upwards doesn't need to be called. Now, with the code done, let's try it out. Yup, that's much better. Now we don't send our enemy into
space!
Okay, that's the recoil done. Now, I don't know if you've noticed, but our enemy doesn't actually do anything right now. Let's change that. We want multiple enemy types in our game, so I want to make this enemy class a base class for all the enemy types to reference. This allows all the enemies to have the same basic building blocks, and we can customize each of them as we see fit. Alright, firstly, we change all the variables we have to protected. A protected variable allows its subclasses to gain access to it, whereas a private variable doesn't. We'll also change the enemy hit and update function to a virtual void. Okay, now we'll add a chase player function. We'll add a protected player controller player and a protected float speed. Serialize this so we can edit it in the inspector. In Awake, add the player controller instance. Alright, as we are making multiple types of enemies with different movement characteristics, we'll leave the enemy script as it is now and create a new script. The first enemy type I'll be creating is a zombie, so let's just name it Zombie. Firstly, we'll change the mono behavior to enemy, so it inherits all the enemy script's functions and variables. We'll then create a protected override void awake and put base.awake in it, so it'll call the awake function from its base class, the enemy class. In void start, we'll set the gravity scale to 12 so it sticks to the floor. Next, we'll create a protected override void update and put base.update. And we'll create a protected override void enemy hit with all the same variables and all that as the base class. Again, I'll call the base function here. Okay, now we get to the player chase. In update, we add if not is recoiling, transform.position equals vector2.move towards transform.position, new vector2 player.transform.position.x transform.position.y. Speed times time.delta time. Alright, let's save all and test it out. Remove the enemy class from the cube and add the zombie script instead. Okay, now let's add an attack player function. First things first, let's create some health for the player. In the player controller, add a public integer health and public integer max health. I'll give this a header, health settings. Okay, now we'll create a function clamp health, so the health can't go beyond the maximum or minimum. We'll add health equals mathf.clamp health 0 max health. The first one is the current health value, the second, 0, is the minimum value, and the last is the max value. Now, we'll add a void take damage with a variable float's damage. Inside, we'll add health minus equals mathf.round to integer variable damage. Next, we'll go to the zombie cube and make the current collider slightly shorter and thinner. Then we'll add another box collider to the enemy. Make this a trigger collider. Alright, now in the enemy script, we'll add a protected float damage. Then a protected virtual void attack. Here, we'll put player.takedamage damage. To call this attack function, we'll create a protected virtual void on trigger state 2D, variable collider 2D other. So if the player enters the trigger collider, we'll call the attack function and attack the player. At this point, the attack technically works, but the enemy will be doing infinite damage to the player as it will run every frame. We only want the player to take damage once instead of every frame. So in the player state list, we'll add a bool invincible. In the enemy attack function, we'll add an if the player is not invincible as well. Now we want to set the invincibility to true after the player has been attacked. So we'll create a coroutine stop taking damage and set invincible to true. Then clamp health, so the health doesn't go to negative. Then wait for seconds, let's say 1 second, then invincible to false. Alright, we'll call this coroutine in take damage. Okay, back in Unity, let's create a take damage animation and call it player_hurt. Link it from any state and to idle, so it can be called from any state and after it has played, it'll transition back to idle. We'll create a trigger take damage for it. Remember to uncheck the loop time as well. Back in the code, we'll trigger the animation immediately after the player becomes invincible. Right, before we forget, let's add health equals max health in void start. We'll also set the max health in the inspector. Before we play, set the enemy to continuous detection and interpolate. Okay, now let's test it out. Excellent, the health decreases. And that's all I have for you in this episode. In the next episode, I'll be covering the mana and spellcasting system. Thank you for watching till the end, and I hope you've enjoyed the video. Want to support what we do? You can help us by becoming a Patreon. This will give you access to the project files for tutorials, as well as Patreon exclusive posts on our blog. Any support you can give will be invaluable to us, as currently we're only making back about 20 cents for every dollar we put into content creation. So, your patronage will go a long way to help us make this a sustainable endeavor. See you in the next video.